Hi, algebra students. This is Miss Vaughn here. So today we are going to talk about the rules for transformations of linear functions. Now, these rules will apply for every single function that we are going to learn this year. Okay, so first we're going to talk about the horizontal shift, or we could call it the horizontal translation. Last year, you guys learned transformations in 7A. You remember, like you did the vertical. I'm sorry. You learned how to rotate a triangle or an image. You reflected it. You translated. So that's the reason why you learned that transformations in 7A, so that you can prepare for algebra, where we're actually going to transform functions. In this case, we're going to learn linear functions. So all of these are notations to help you figure out what the rule is saying. So when you have f of x plus h, when you see that, because the actual equation it says itself is subtraction. So inside, if you see if it's h is positive, then you're actually going to move to the left, however many units it states. So in this case, this means we're going to move to the left. All right, let me see if I can do a laser pointer. Cool, perfect. So now what we're going to do is, okay, so now if I have f of x minus h, that h, because it's being subtracted by h, that means that it's going to shift whatever units to the right, okay? Or you could say translate the units to the right. We'll talk about examples in the next video. Then we have f of x plus k. Now this is what we call a vertical shift or a vertical translation. So that means you're going to translate it up or down, versus horizontal, you move left or right. So if I took f of x, meaning if I took a function and I add a number to it, it's going to change the y-intercept. So that means I'm going to shift it up. Okay, so if I add it, it's going to shift up. If I have f of x minus k, I'm going to shift the whole graph down a certain amount of units. Then we're going to talk about reflection. If you multiply the whole function, like let's say we multiply the whole equation by a negative, it's going to change the slope. It's going to change the y-intercept. In that case, we call that a reflection across the x-axis. Now, if I do f of negative x, that tells me that all I'm changing is the slope. Okay, it's going to change the slope. It's going to make it negative slope, or whatever the opposite of it is, and that's going to be a reflection across the y-axis. Now, this example you saw in the Desmos, so definitely make sure you take note of that, okay? But this is a great diagram that you should be printing out for yourself or copying down for yourself. Now, there's something called a vertical stretch or compress. We can call that shrink. So in our textbook, they call it a shrink. So vertical stretch, and they call it a vertical shrink. Okay, so just so that you guys know, sometimes depending on the textbook, they might call it compress. All right, so an example. If I took a factor and I multiply it by the whole equation, it's going to make it a vertical stretch by a scale factor of a. Now, last year you guys learned about dilation, so this kind of refers to that dilation part of it. Meaning, you know how like you had a triangle and you made it bigger. That's you're making an enlargement there. So that's the whole idea of that. Okay, but we're stretching it this time because it's a line. All right, then you have a times f of x when a is in between 0 and 1. So that's mean like a fraction, for example, like 1/2. In that case, we're going to call that a shrink or vertical shrink by a scale factor of a. So whatever that is the scale factor. Now here's the tricky part, okay? This is only occurs if it's within, it's causing the x to change, just the slope. Okay, in this case, the vertical stretch and the vertical shrink here on this part of it, you're changing the whole equation. You're multiplying slope and y-intercept by a. Okay, now then you have something called the horizontal stretch or the horizontal compress, or you could call it the horizontal shrink. In this case, you only multiply just the slope. Okay, so f of a of x, if a is bigger than 1, we're going to call that a horizontal shrink or compress. But look at the scale factors, a little bit different. Okay, the scale, it will be like a shrink, horizontal shrink by a scale factor of 1 over a, because you do 1 divided by that number. Okay, we'll look at examples for that, so don't worry about that. All right, and the last one is f of a of x is if when a is in between 0 and 1. We would call that a horizontal stretch by a scale factor of 1 over a. All right, so right now I want you to use this diagram to help you with your IXL. So we are going to head over to IXL and we're just going to do a couple of problems together. All right, guys, so we're going to go through a couple of questions together, and I'm going to show you, I'm going to use the table of information, and I'm going to apply it to the Excel, okay? And that's what you guys are going to do to practice as well. So here's the first one. It says, what does the transformation f of x changes to f of x minus 5? So that rule tells you, if I look at here, if I look at all the information, I can say, okay, f of x minus 5, that goes right here. That's a shift right a certain unit. So they want you to go right 5 units. So that means translate it 5 units to the right. All right, we got 10 points out of 100. Okay, so we take a look at the next one. So you can see the rule states that f of x transform to f of x minus 6. So they want you to subtract 6, right? So, okay, so we'll look at the table again. So that means that it's going to shift right as well. So we're going to go translate 6 units to the right. Here's another one. Okay, now this is your k because I'm taking the actual function and subtracting 8. So I'm going to go ahead and look at that. It's a vertical shift, and that is this one right here, f of x minus k. See, f of x minus 8. That means it says to shift down so many units. So we're going to go down 8 units. So translate 8 units down. And hit submit. Pretty easy, right? Let's keep on going. Now, this is a little bit tricky because now they have multiple transformations that they're asking you to do. Okay, so you can see here that they have f of x plus 2, so we're going to look for that. And they have plus 9, that's your k. So they not only they want you to do a horizontal shift, they also want you to do a vertical shift. So let's take a look at the rules. F of x plus 2, so that's right here. That means it's going to move 2 units to the left. Okay, so we're going to do 2 units to the left. And then it says plus 9. Then it wants you to take the whole function, f of x plus 2, then add 9. So that means we're going to take the whole function, add 9. So you have 2 transformations for this one. It wants you to go to the left 2 units and up 9 units. So translate it 2 units to the left and 9 units up. All right. Okay, let's take a look at the next one. We have f of x minus 1 plus 9. So this one has 2 transformations that they want you to do. So the 2 rules states that we have x minus 1, so that's horizontal translation. So that means they want you to move 1 unit to the right and 9 units up. 1 unit to the right and 9 units up. So translate it 1 unit to right and 9 up. All right, let's do another one, okay? So now we kind of get better at just looking at the rules and knowing what they're asking you to do. So now I can say, you know what? It wants us to move 6 units to the right and 9 up just by looking at my chart. So 6 units right and 4 units up. 6 to the right, 4 units up. Just wanted to check to make sure I did that right. Okay, let's go ahead and take a look at the next one. So make sure you keep on going through it because it's going to do some more challenging questions. So this is f of x plus 2 plus 4. So 2 units left, up 4. Translated 2 units left, up 4. 2 units left, up 4. Okay, now we're going to look at this one here. We're going to see which one this one looks like on our chart. So f of x transforms to f of 4 times x. And now 4 is being multiplied just whatever x is. So you're just changing the slope. So that's just a hint right there. But if you look over here, we're going to look at that. If that number is greater than 1, we know that this is going to be a horizontal shrink. Horizontal shrink with a scale factor of 1/4 or 1/4. Now, this here, they just tell you the rule, but you don't have to do the scale factor. When we do the big ideas, there will be a scale factor. Okay, so this would be a horizontal shrink. Okay. All right, using the table. Then we have f of x transforms to 1/2 of f of x. So I'm going to look at my table here. I'm going to go look for when my scale factor is between 0 and 1 because it's 1/2, and you're multiplying the whole function. So this has to be this over here. Sorry, guys, right here. And so we would call this a vertical shrink by a scale factor of a. So this is a vertical shrink. All right, we had 64%. So then we have f of x transforms to 1/6 times f of x. So same thing, that is in between 0 and 1. So this is a vertical shrink by scale factor of 1/6. I'm just adding that in there. All right, okay, so now here are some reflections going on because I know there's a negative there. So f of x transforms to f of negative x. And I'm going to look over on this side, and that is a reflection because it's being multiplied by negative, and that's my hint. I have to figure out if it's going to be across the x-axis or y-axis. If the negative is inside the parenthesis, that means you're just changing not the whole equation, you're just changing the x, which is the slope, the coefficient there. So it's going to be a reflection across the y-axis. So hopefully you guys are getting the idea. I'm going to do one more so you guys can see. So f of x transforms to f of 1/7 x. And so that is going to change inside and is in between 0 and 1. So we're going to say a horizontal stretch. Okay. And you keep on going to practice that. And all I did was use the table to practice that so you understand before we move on to the next lesson.